COVID pandemic accelerated brain aging in everyone, study finds. The COVID-19 pandemic appears to have hastened the aging process of our brains, affecting everyone, even those who never contracted the virus. And this is the part most people might overlook. The environment and stressors linked to the pandemic had tangible effects on neurological health, regardless of infection status. But here's where it gets controversial. Does that mean simply living through the pandemic, without catching COVID-19, can still accelerate brain aging? Recent research involving nearly 1,000 individuals reveals that the brains of generally healthy adults showed signs of faster aging during the pandemic period. This was determined through brain scans that observed structural changes typically associated with aging, occurring more rapidly than in similar groups before the pandemic started. Remarkably, this acceleration was seen in people who remained uninfected, suggesting that external factors related to pandemic life, like social isolation, disrupted routines, stress, and economic uncertainties, can impact brain health. The study found that the most significant effects were among older adults, men, and individuals from less privileged backgrounds. These groups are often more vulnerable to stress-related neurological changes, which might explain the noticeable difference. Interestingly, when they tested cognitive functions, such as mental flexibility and processing speed, they discovered that only those who had contracted COVID-19 showed measurable decline. This implies that while structural brain aging increased across the board, the functional impact, like cognitive decline, seemed mostly linked to those who had been infected. So, why does this matter? It emphasizes that our daily environment and emotional well-being are deeply tied to brain health, perhaps just as much as direct illness. The big question now: can this pandemic-related brain aging be reversed or mitigated? The current research only measured brain scans at 2 points in time, making it difficult to determine whether these changes are permanent or temporary. Future studies will need to dig deeper into the mechanisms behind these findings and assess whether the effects will linger long-term. Moreover, analyzing additional factors like mental health, social support, lifestyle, and stress levels will be crucial to fully understand how the pandemic environment influences our brains. Consider this a call for a broader perspective on brain health. You might be surprised to learn how much external stressors can shape your neurological aging, even if you stay physically healthy. Do you think these findings should change how we approach mental well-being during stressful times? Or is there more to uncover before jumping to conclusions? Share your thoughts in the comments. There's plenty of room for debate here. How the COVID-19 pandemic aged our brains by 5.5 months. Unprecedented times have taken their toll on our minds, with recent findings revealing that the COVID-19 pandemic has accelerated brain aging by an alarming 5.5 months on average, even among those who remained uninfected. This revelation, published in Nature Communications, has sparked discussions about the long-term impacts of global crises on mental health. A team of British researchers delved into extensive brain scan databases to uncover this startling truth. They discovered that during the pandemic years of 2021 and 2022, individuals' brains exhibited signs of premature aging, including shrinkage. This observation was particularly pronounced in males and those from less affluent backgrounds, highlighting the multifaceted influences on brain health beyond mere illness. Those who contracted the virus faced additional challenges, displaying cognitive deficits in areas such as processing speed and mental flexibility. This finding underscores the intricate relationship between viral infections and neurological health. The study, led by Alireza Mohammadi-Nejad, a neuroimaging researcher at the University of Nottingham, utilized the UK Biobank, a vast repository of health data from over 500,000 volunteers recruited between 2006 and 2010. By comparing pre-pandemic brain scans with those taken during the pandemic, the researchers were able to estimate the acceleration of aging. Interestingly, the disparity in brain aging between genders was relatively small, averaging around 2.5 months. However, the reasons behind this gender difference remain elusive, though it aligns with previous research indicating that men may be more susceptible to specific forms of stress or health issues. Brain shrinkage, a natural part of aging, can lead to memory loss and impaired judgment when it occurs prematurely. While the pandemic study does not directly link structural changes to cognitive decline, it raises concerns about potential long-term consequences. The exact causes of this accelerated aging are yet to be pinpointed. However, the researchers suggest that the cumulative effects of the pandemic, including psychological strain, social isolation, disrupted routines, reduced physical activity, and overall wellness deterioration, likely played significant roles. In essence, the pandemic period itself seems to have left a lasting imprint on our brains, irrespective of direct infection. Previous studies have shown similar outcomes, particularly in adolescents. Research from the University of Washington revealed that teenage brains aged prematurely during lockdowns, with boys experiencing an extra 1.4 years of aging and girls an additional 4.2 years. These findings emphasize the profound impact of societal upheavals on developing minds. To establish a baseline for normal aging, the researchers analyzed imaging data from 15,334 healthy individuals collected before the pandemic. This dataset allowed them to train their model to recognize typical, healthy brain aging patterns throughout adulthood. From there, they examined a subset of 996 participants who underwent 2 brain scans, with the second occurring approximately 2.3 years after the initial scan. Of these, 564 had both scans before the pandemic, aiding the AI in understanding brain changes in non-pandemic conditions. The remaining 432 participants had their second scan post-pandemic onset, primarily between 2021 and 2022, providing insights into the pandemic's effects on brain aging. Despite the scans being conducted later in the pandemic, they still reflected changes that likely occurred during its peak, when disruptions were most severe. Other studies have implicated environmental factors in premature brain aging, such as one conducted in Antarctica linking isolation to brain shrinkage. One of the study's most intriguing findings is that cognitive deficits were exclusively observed in those infected with SARS-CoV-2, despite structural aging in others. This distinction hints at the virus's direct impact on neurological functions. While the study does not clarify whether the observed structural changes in non-infected individuals will manifest as functional brain alterations, experts like Jacqueline Becker, a clinical neuropsychologist at the Icahn School of Medicine at Mount Sinai, note that it sheds light on conditions like long COVID and chronic fatigue syndrome. Adam Brickman, a neuropsychology professor at Columbia University Vagelos College of Physicians and Surgeons, cautions that the study presents a compelling narrative but remains a hypothesis. It does not confirm whether the accelerated aging in non-infected individuals will persist long-term. However, there is hope. Engaging in activities that promote brain health, such as exercise, maintaining healthy blood pressure, ensuring adequate sleep, and fostering social interactions, may mitigate these effects. As we continue to navigate the aftermath of the pandemic, prioritizing mental well-being becomes more crucial than ever. COVID-19 accelerates brain aging, uncovering the hidden effects. The devastating impact of COVID-19 has left an indelible mark on our health, and a recent study reveals a shocking truth: our brains are aging faster due to the pandemic. This eye-opening research, published in Nature Communications, suggests that the pandemic's effects on our brains are far-reaching, impacting even those who remained uninfected. Led by Alireza Mohammadi-Nejad, researchers analyzed brain scans from 1,000 individuals, comparing pandemic-era scans to those taken during normal times. The results were startling. Pandemic-era brains appeared to age approximately 5.5 months faster than those studied before the pandemic. But here's where it gets controversial. This accelerated aging was observed in both COVID-19 patients and those who never contracted the virus. The changes in gray and white matter, critical for memory, emotions, and nerve signal transmission, were similar across the board. This finding was intriguing and somewhat unexpected, Mohammadi-Nejad commented. While previous studies have linked the COVID-19 virus to negative brain changes, this study suggests that the broader pandemic experience, including stress, disrupted daily routines, reduced social interactions, and decreased activity, also played a significant role. The impact of the pandemic was particularly pronounced in certain groups, including men, the elderly, and those with compromised health, lower education and income levels, or unstable housing. For instance, individuals with less stable employment showed an average of 5 months of additional brain aging compared to their more secure counterparts. However, only COVID-19 infected individuals exhibited drops in cognitive skills. This raises an important question: are we overlooking the broader health effects of the pandemic beyond the physical symptoms that typically grab doctors' attention? Brain health is influenced by our daily activities, and major societal disruptions like the pandemic can leave their mark even on healthy individuals, Mohammadi-Nejad emphasized. He suggests that strategies to maintain brain health, such as a healthy diet, exercise, sufficient sleep, and social and cognitive engagement, are crucial, especially during stressful times like a pandemic. And this is the part most people miss. The study didn't explore specific ways to reverse brain aging, but it does highlight the importance of considering mental, cognitive, and social well-being alongside traditional physical health indicators when planning for future crises. So, what do you think? Is this study a wake-up call to prioritize our brain health during challenging times? Or do you have a different perspective on the matter? Feel free to share your thoughts in the comments below.